Section 4.1 is on page 206. Talks about polar coordinates. Here, polar coordinates are normally referred to as r and theta. So instead of x and y, it's r and theta. The polar grid consists of the positive x-axis. It looks like this, in which this right here is called the pole, which is the origin. And do remember, identical to trig, this is how we rotate positive, and this is the negative rotation. So the way it works for now, it would be best if you would rotate first, then r comes after. If r is positive, you would move towards theta. And if r is negative, you would move in the opposite direction or away from theta. I'll point this up again, and we have the first set of examples to do that. And this is just to plot a point, something we're going to get used to. And let's get that out of the way. It turns out this first batch of problems is a must for the next section. The next section is among the challenging sections, something that you need to carry with you. And to be able to do that, you need to really understand this first set of problems. This part, how to plot points, nothing else. So number 19 through 32, we want to do a few of those. So we need to be able to plot a point before I can plot an entire curve. I need you to really get this out of the way. So on your homework, on 11 through 31, I suggest you take that very seriously. Let's do a few of those. What I mean by few, let's do all the evens. That's few. That's how important this is. And hey, 28. We almost missed 28. So that should be all the evens, right? Okay. So, rectangular coordinates. We take the x-axis, the y-axis, and we kind of create a bunch of rectangles, and that's where the name comes from, rectangular coordinates. Here we go. So, if I take oh, come on. Okay, you know what? If you can't beat them, join them. So, when I go to r equal 1, r equal 2, r equal 3, r equal 4, since I am moving in a rotational, I wouldn't draw a rectangle, I would draw a circle. So that's how the grid looks like. It looks like a bunch of circles. And of course, this is not that pretty. I already made one for you. Okay, as soon as I can put this mouse to work, here we go. And here it is. Okay, much better. So now, if I look at the very first, number 20, we're going to rotate first. We're going to rotate a full revolution to 270 degrees, 3/4 of a revolution. So when we rotate, now keep in mind how this works. In polar grid, it's unlike the traditional grid in the sense of you already start with direction. Do you see that arrow right there? It's like a flashlight. You're indicating that you're pointing in the positive x-axis. When I rotate, that arrow doesn't change. So it's right here. When I rotate to 90 degrees, when I rotate, and that's what we mean towards. Away would be in the opposite direction. So when I look at the very first problem, for I am pointing now in this direction. I rotated, I was on the positive x-axis, rotated, pointing in that direction like a flashlight. As I rotate 270 degrees now, I'm pointing in this direction. If theta is positive, if r is positive, I move in that direction. R is a positive 4, I move 1, 2, 3, 4. All of that work for that point, and that's number 20. Now, number 22. I rotate to pi. I am, again, starting with the positive rotation, positive x-axis, pointing in that direction. When I rotate to pi, isn't rotating to pi, you're right there now? Since r is negative, I would move not in the direction of pi, I would move in the opposite direction 1, 2, 3 units. When I look at number 24, 5 pi over 3, I rotate to 5 pi over 3. 5 pi over 3 is right there. So I am pointing in this direction. This is 5 pi over 3. If r is positive, I'll be in quadrant 4. But since if r is negative, I'll be in quadrant 2. I'll move in that direction 1, 2, 3, 4, 5. And that would be number 24. This was number 22. And if I go for 26, rotate 120 degrees. Isn't 120 degrees right there? So I'll go to 120 degrees, and let me get that in. Okay, I added those, the blue for the 30s and the green for the 45s. So let me continue on. We are looking at negative 3 pi over 4 is right there. So basically now you're pointing in this direction. And since r is negative, you're going to move in the opposite direction 1, 2, 3 units, and you are right there. You could do the same in the homework. You could go ahead and figure out, draw one of those circles and just do the whole homework on one of those. That's fine. On number 32, I need to know where negative pi over 2 is. That's right there. So now you're pointing in this direction. But since r is negative, you're going to move in the opposite direction 3 units. And this would be number 32. And as for the last problem, negative 5 pi over 4 is right there. So you're pointing in this direction. And since r is positive, you move in that direction 2 units. And that's number 28. So we're going to do other things now, but out of everything that we're going to do, you should really get this part out of the way before we tackle the next section. Otherwise, this is going to prove to be a lot more challenging than you think. Okay, now, given x and y, how would you move to r and theta? And given r and theta, how would you convert or move to x and y? two things that you have to do. It doesn't seem like it matters a lot in this class, but it matters a lot when you take calculus. It's a massive deal. So given x and y, let's say I'm given a point right there. Well, wouldn't this be the x? Wouldn't this be the y? So the r and theta that I'm looking for, isn't that r and that's theta? So given the purple, isn't r squared x squared plus y squared? And given the purple, and if I want to find theta, I have an angle, the opposite and the adjacent. Wouldn't you say tan of theta equals the opposite over the adjacent? There it is. Given r and theta, if I want to figure out what x and y would be, well, oh, that's annoying a bit. Just a bit. R and theta consist of this positive x-axis. Don't you rotate some theta and you move some distance? And that's r. Well, guess what? If I run down and I say, hey, look, that's x and that's y, given the purple, given in a right triangle the angle and the hypotenuse, if I want to know what x is, that's an angle, the adjacent and the hypotenuse, I would say that cosine of theta is the adjacent over the hypotenuse, which means x equal r times the cosine of theta. And if I look at y, I'm given the purple, I'm given the hypotenuse and an angle. I want the opposite. The sine of theta would be the opposite over the hypotenuse, which indicates that if I cross multiply, y is r times the sine of theta. So pretty much there's everything that you need to know about converting forward and backwards. Okay, I'm going to stop this video here before I do a problem because I'm running into a lot of trouble trying to do some. Actually, we could do fit a couple of problems in. So let's look at the next set of problems. Wrong book. So they're going to start off with points. We're going to take a point in polar coordinates and convert that to rectangular coordinates. And we want to do a few of those. Actually, let's go for it. I don't think we're going to have that much time, but let's see how this works. A couple of ways you could do this, and I don't mind how you do it. Okay, so one way you could plot the point and figure that out if you wish. See how that works. That is, you could say, well, I'm going to rotate the 3 pi over 2. So rotate the 3 pi over 2. I am pointing in this direction and move 4 units. I'm right there. You could say automatically, hey, I know what that is. In x and y, don't move to the left or right and move 4 down and we're fine. That's one way of doing this. Another way of doing this, so you're done. You could do that. That doesn't work on all the problems. This is an exception. Or you could say, you know what? Given r and theta, I know that x equal r times the cosine of theta. So x equal 4 times the cosine of 3 pi over 2, x equal 4, cosine of 3 pi over 2 is 0, that's 0, y equal r times the sine of theta, y equal 4 times the sine of 3 pi over 2, and y would be 4 times negative 1, which is negative 4, and therefore it's the point 0, negative 4. How do you do this? I can care less, but you should become very comfortable with points. Right, I'm going to stop here and start the next lecture with the next problem up.